much for coming in here, and apologies from Dietmar, who was supposed to give this introduction. But so this project is part of this wider scheme of things that includes our strategic research innovation, excellence innovation grant, and also Center for Translational Data Science City Informatics Hub, EarthByte Group, and School of Geoscience. So a number of people are involved in this project. And our goal is to provide uncertainty quantification in parameter estimation for models in geoscience. And so basically, the way we have set this workshop is that first 30 minutes we will have just some technical installation of the Bayeslands framework. And then afterwards, I will give a 40 minutes, I will try to keep it to 40 minutes, a 40-minute seminar that sums 2 papers up, the results. And then afterwards, after that, we'll take a short break, and then we will have, we will walk you through each part. Nathan and Daniel is here, and they have been our technical guys for this project. And then there's Arpit and Konak there to help as well. Let's begin, right?
Let's get into it.
I'll leave this to you, Nathan.
Thanks. So, hello. I know a lot of you. So I'm Nathaniel Butterworth, or Nathan. I used to be part of the EarthByte group, and I've since moved on over to Sydney Informatics Hub, which is like a kind of like a faculty or research support group in the university. We provide sort of services and collaborate with people on all different projects over the university related to high performance computing and like data analysis and things like that. So we work with a lot of people who don't traditionally have skills in like data analysis. So that's sort of how I fit into this, and I got pulled into this project and then have been working on it. And yeah, we put these sort of notes together. Hopefully everyone has managed to go to the website. We've got a GitHub repository where we've put up lots of these notes for today. So Bayeslands is what we're talking about today, but that is built upon the Badlands modeling code. So who here knows what Badlands is? Tristan, hopefully. So Tristan's. So okay, good. So everyone's familiar with Badlands to some extent. Who's used Badlands? Has everyone used it? Or yep. Okay, so a few. Yep, that's good. So everyone's familiar with Python? Yep, mostly. Jupyter Notebooks, maybe. Yeah. Okay. All right. Cool. So everything we're doing today is in Python within the Jupyter Notebook environments. So hopefully everyone has sort of some understanding of that, and everything should be straightforward. Now, I'm just going to run this. So there's a couple ways to install the to install all the workshop materials for today. The easiest one, I guess, or the most straightforward one, is to download the Docker file that's on there, and then just execute a few commands. It takes about 5 minutes to build. So I've already downloaded this Docker file. It looks like this. You can either clone the whole repository, or else you can copy and paste that into a document, or you can get it from the Docker online repository. So I'm just going to start a terminal over here. Let's see.
Just a quick question. Did you record?
Yeah. Okay, so here we go. I'm just working. I'm going to work on my desktop. You can follow along if you haven't done this. I'm going to clone the whole repository. So I'll go back over here, and that way. So if you work within the Docker environment, then nothing will be persistent. Oops, that won't work. Will it? That won't work. So yeah, if you work within the Docker environment, nothing will be persistent, which is good and bad because you can mess around with things and you can just sort of restart it if you mess things up. But if you sort of want to keep all these notes and all the things that you make and change, then you probably want to build everything from source, which can be straightforward or else hard if you've messed anything up on your computer, like myself. So it's about 30 megabytes thing. Cool. So I've now got this new folder here called Bayeslands Workshop, hopefully. Bayeslands Workshop. And I'm just going to go into the directory where I downloaded the Docker file. So there's the Docker file. You can look at it if you want. And I'm just going to run these commands here, which are, let's see, docker build -t Bayeslands, and that should take, I'll build it. I've already built this, so I'll just put it with the no cache command so I can build from scratch. There we go. Which will take about 5 minutes or so. So is everyone at this point? Who hasn't got it yet? Anyone? Everyone's got it? Am I wasting my time here? Great, this is fantastic. Okay, so now we just have to wait for mine to build. When it does finally boot up, you should be in a Jupyter, or it'll actually give you a link to an environment. I couldn't figure out how to automatically start the web browser. That was not really outside the scope of this course. So okay, almost there. Just compiling. Hopefully, no errors. All right. Okay, and so we're just going to follow a series of notebooks. We're going to follow this one first of all. It's called starthere.ipy notebook. If you've done any of Tristan's courses before or seen the repositories for Badlands, then some of these will be very familiar to you. Okay, so that's built, great. And then to run it, I'm just going to do docker run -p and run it on port 888. Okay, so it says the Jupyter Notebook server is running at 000,888. So I'm just going to copy this into a web browser, and here we go. So this is all within our Docker environment. Looks good. Looks like it should. Oops. Up here.
Yeah, I can just share the terminal. The terminal is not shown in the share.
Okay, right.
So
I think I can only share one at a time.
You can just share the whole desktop. You can just share the whole desktop, the one on top.
Okay, cool.
Yeah,
great.
Share that one. Yeah, that's great.
Cool. Okay. That's all right. It's just you and me connected.
Yeah.
So, all right. So if you click on the Start Here document, this basically replicates the README that was there before. I'm just going to get rid of the toolbar so we have a bit more everything to display. And okay, so from here we're just going to go through a couple of examples. Now, Rohit, did you want to introduce Bayeslands here, or should we just go through the basic Badlands ones first?
No, I think you could take this time so that everybody runs the basic.
Is everyone up to here?
Like, can they run the one Docker?
Everyone's got it? Great. If everyone can see this screen at the moment, then we're doing well.
Yes.
How good's that? How good's Docker? This is my first experience with Docker. It's
so
really well.
After 5 minutes, I will start the seminar.
Okay, sure.
Yeah, so
all right, so, so the very first thing we thought we just might start early. If you're familiar with Badlands, then this should be straightforward.
You could start the standard Badlands and then afterwards
yeah.
we could end.
Okay, so we're just going to firstly show you kind of how to build a generic surface in Badlands. And this is used as input into the geodynamic modeling code, which I guess simulates surface processes. Feel free to jump in at any time if I say the wrong thing, Tristan. Thanks. So, hello, Sabine. Welcome.
Hello. I'm sorry, I'm late.
And yeah, if you're familiar again with the Jupyter notebooks, pressing Shift Enter should run a cell. The first cell is just in Markdown language, so there's not much to show. But we're making a couple of simple grids, which eventually will be input into Badlands. So we're building up sort of these different input files that we use as our initial surfaces. So imagine things like today we're going to be using examples of like a crater. So imagine a crater has formed somewhere in the world, and you want to try and understand how that crater may have got to where it is in its present day position. Imagine it probably a meteorite struck there, it formed this sort of big crater shape, and then over time it's eroded away to its present day shape. So that's what we're trying to do. We're trying to capture that evolution and understand the parameters that may have been around happening in that environment to make the crater where it is in its present day. Okay, so the first thing, this first cell, we just import a couple of things that we need and set up our environment. So we're going to plot things, then we're going to build a regular surface. So the function that we're using, this tool geo, takes 3 different arguments, and when you run it, not much should happen. If you're not familiar with Python too much, you can type in help on these things, and it'll print out sort of what's in the function there, so you can learn more about these sorts of things. And the very first thing we're building, so we build our something called a slope. So we're building a slope, we get help on the slope, and finally we view it. There we go. There's our very first thing that we may use as input to Badlands. It's a nice little slope there. Could be the edge of a continent or something. You might be curious how that's formed. Something simple. But yeah, basically we have to set up the grids here that we're making for Badlands to interpret. So Badlands has specific input requirements that it needs. Yep. I'll just move on. So then this is this all clear so far? Like, we're not doing anything groundbreaking at the moment. These are just sort of designed so you can take them away and recreate these things yourself, these examples with your own data. Maybe you don't want to make a slope. Maybe you want to make a wave type structure here. So you can sort of build up more and more complex structures using a few of the inbuilt things in Badlands, these inbuilt functions, and there's a nice dome for you. So anyway, you can keep going and do things like that. And meanwhile, this has been outputting data for us in our, if we go back to our Jupyter Notebook sort of navigator, in the examples folder is sort of all the notebooks that we're running today, and we've just created these CSV files, and they're the inputs into the Badlands. So, okay, awesome. So that's how you make simple input, and then we'll jump straight. Any questions so far? Okay, good. Okay, more realistically, you might want to get the topography from some area that you know. So we're just going to use the eTopo1 data set. Everyone's familiar with topography and everything. You know what topography means? Cool. Okay. Yeah, we're just taking an example here where we're going to use this data set to go and get a section of New Zealand and cut it up and build a grid that Badlands can then input. So again, we run our import function. So we build up our grid here. We specify the latitude and longitude of what we want. So, and then we can display this using this grid plot EPSG function. So we're in the northeast region of southern New Zealand. There we go. There's a nice, pretty little map for us. And now we're going to extract the data set from the eTop01. All right. Should make a nice map for us. Beautiful. There's our topography and bathymetry. And then you can export the grid. That'll build it for us, and we can also view it at the end here. Here we go. Great. So now we have a bit more complex, a bit more realistic example. And so then you put this in Badlands, and you might want to know how it got to its present day state. So you might try and build a topography that may have been what it looked like in the past, and then you're trying to essentially figure out what the parameters are, like the rainfall, the erodibility that forms this sort of environment. Or you might want to know what happens to it in the future. So you set these parameters and let Badlands run, and that will erode away, and the sediments and things will move around within the model, and you'll get a sort of different output. Okay, cool. So that is building our inputs. Now, so everyone's comfortable? Nothing groundbreaking? This is great. This is good. Everyone's far more advanced than I was anticipating. Okay, so we're just using it. One more example before we get into sort of the meat of things. This is just how to run a simple Badlands experiment using specifically PyBadlands. So if you're sort of unfamiliar with Badlands, PyBadlands, Bayeslands, Badlands, the original modeling code. PyBadlands is sort of an extension that lets you interface with Badlands via Python and run things in Python. It just makes it a lot easier to get at the parameters and things like that. And you can run the whole thing in Python. And then Bayeslands is sort of the extension that we've added on top of that. Okay, so this one where we've got a mountain here, where and we want to sort of see what happens. We start with like a flat environment, and we let Badlands sort of provide uplift and erosion, and we should create a mountain environment. So this is the call. This is sort of like an important call here as we load in the Badlands model, and we read everything in from this XML file, and that sort of defines the entire model for us. So if you're not familiar with Badlands, that's sort of the where Badlands is being told everything that happens. So when we load that in, probably tells us just some information about it. You can have a look at the XML file. If you feel like it, you can edit it. You can see that it points to that mountain/data/nodes. That's that's the initial input surfaces that we've just been building, so things like that. You set how long the model is going to go for. You set things like how much uplift there is, and you can also define a file that describes how much uplift there will be and where on that surface uplift occurs, and how much rain and things like that. So that's what's happening in the XML file. So that's an important part to know. And then we can change it all. PyBadlands so it gives us the ability to adjust parameters as we see fit. So if we don't like something in the XML, the beauty of PyBadlands is we can just go, oh no, I'm going to update this to be this value instead. So I've just made a few slight changes there, setting the M values and the erodibility, and also the rainfall value there. And all right. And then you can get help on the load XML function too. All right, finally, this is it. We have the model here. We're just going to time how long it takes, and we're going to run it for a million years. Here we go. And so each of these models, the simple Badlands models, take a couple of seconds to run. Some of the more advanced ones, continent scales, might take a few minutes, even longer. So yeah, it took 7 seconds to run the whole thing. And then that would have created a whole bunch of, whoops, let's see, boy, so that would have created a bunch of, oops, output. Where's it? Oh yeah, so we created a test output. So that created all this output in there that we can look at in ParaView or something like that. Or here's a nice little animation of what's going on there. So it starts as a flat surface, and then this mountain rises up as it erodes away. So, all right, so that is Badlands in a nutshell. Now from here,